Right now, there are companies across the globe paying, honestly, upwards of $300,000 a year
Oh.
for a role that, well, basically didn't even exist 3 years ago.
Yeah, it's pretty wild.
Right. And the main skill required for this highly lucrative job, it's just knowing how to talk to a machine in plain English.
Well, plain, but very specific English.
Exactly. So today, we are doing a deep dive into the hidden architecture of prompt engineering. We've got this massive stack of sources, comprehensive guides, technical breakdowns, definitions, and it's all centered around how we actually interact with artificial intelligence.
Because, frankly, most of us are doing it wrong.
We really are. So our mission for this deep dive is to, move way past those simple, frustrating chat queries and uncover the actual science of what's happening under the hood.
Which is a huge fundamental shift in how we need to approach software. Like if you're sitting there right now wondering why your marketing copy prompt keeps spitting out just generic, unusable garbage.
Well, we all been there.
Right. Or why your data analysis request gives you a completely fabricated spreadsheet. It's because, well, you're treating a probabilistic engine like a basic search bar.
Yeah, to frame this for you, typing a casual one-sentence query into an AI, it's essentially like jumping into a taxi, slamming the door, and just yelling, "Drive."
That is a perfect analogy.
Right. Like, the AI doesn't know your real intent.
Mm.
You expect it to work perfectly, but you haven't given it turn-by-turn directions. So the system either crashes or, takes you to the wrong state entirely. Prompt engineering is the act of giving those directions. It's setting the environment variables, establishing constraints.
Building the bridge, basically.
Yes, exactly.
Prompt engineering operates as this necessary bridge between your human intent and the model's token-based architecture. And tokens are really the foundational unit we need to understand here.
Because the AI doesn't actually read words, right?
You're right. Exactly. The AI does not see your frustration. It doesn't know your business context or your quarterly goals. It only sees tokens, which are just chunks of words or characters that have been converted into mathematical vectors.
Right, and it's basically just calculating the statistical probability of what the next token should be based on the billions of parameters it learned during training. It's an incredibly sophisticated autocomplete.
Yes. Sophisticated, but still an autocomplete at its core.
So if you just type, "summarize this report," you're giving the model almost zero parameters to work with. You're basically dropping a pin in the middle of a massive multi-dimensional probability space and just asking it to guess.
And the math supports that entirely. When you provide a vague prompt, the probability distribution for the next valid token is incredibly wide. There are mathematically millions of valid ways to finish a generic sentence or complete a vague task.
Okay, wait, let me play devil's advocate for a second. So when I just type a quick, casual question into an AI, I'm literally leaving the model to just guess my intent based on probability. Isn't the AI supposed to be, smart enough to figure it out?
See, that's the misconception. It isn't guessing intent at all. It's predicting tokens. A vague prompt leaves too vast a probability space, which is exactly why structured engineering is required to steer it. The vastness of that space is the direct cause of hallucinations.
Hallucinations, that's when the AI just confidently lies to you, right?
Yeah, generates completely fake facts. Because it doesn't have enough constraints, it wanders into irrelevant areas of its training data and just strings together statistically plausible but totally factually incorrect tokens.
Oh, wow. So it's not broken, it's just wandering.
Exactly. And beyond just getting a bad answer, there's a hard economic reality to this for any business deploying AI.
Oh, right, the API costs.
Yeah, if your users are entering poorly engineered prompts, they're forced to regenerate the answer 3, 4, or 5 times to get what they actually need. And since API costs are calculated per token, those retries directly multiply your infrastructure costs.
Oh, yeah.
Plus, computing an unconstrained generation takes longer, so you're suffering from increased latency, too.
Right, so you're paying more money for a slower, worse answer.
Exactly. So structuring the prompt effectively narrows the context down to a highly specific probability lane. This ensures the correct answer on the first pass, minimizing token usage and drastically reducing latency. It's literally an economic necessity.
Okay, so if leaving things to raw probability wastes tokens and creates these hallucinations, we really need to look at how to build that bridge. Based on the sources we looked at, what does a structured, reliable prompt blueprint actually look like in practice?
So the sources outline a very specific 4-part structural blueprint, and it moves far, far beyond just speaking politely to the machine.
No more please and thank you.
You can, but it doesn't really help. First, you must establish a clear task definition. This requires using highly specific, actionable verbs. You want to avoid passive instructions like, look at this data.
Right, you need to specify the exact function, like summarize, translate, extract,
Classify,
right.
generate test cases, yeah.
But just telling an AI to summarize isn't really enough if it doesn't know whose perspective it should be summarizing from. Right. I mean, a senior cloud architect looks for very different details in a tech document than a sales director would.
Which brings us directly to the second element of the blueprint, role and perspective. By stating, you are a senior cloud architect, you aren't just doing a fun role-play exercise. You are effectively applying a massive negative weight to tokens associated with, say, amateur coding blogs or generic marketing speak.
Oh, that makes sense.
And at the same time, you're applying a massive positive weight to AWS documentation and enterprise system design patterns. You are pruning the probability tree.
I love that. You're pruning the tree. It's kind of like casting a movie. You don't just point a camera at an actor and say, act. You say, you are a 1920s detective. That's the role. Solve this specific crime. That's the task.
That's a great way to think about it. By locking the persona in, you slice away 99% of the internet from the model's active probability space.
Okay, so we have the task and the persona. What's the third component?
Establishing context and constraints.
Like setting the boundaries for the actor. Don't use modern slang.
Precisely. You define the target audience, provide necessary background information, and explicitly list the do's and don'ts. If you're generating an explanation, are you targeting a 5-year-old or the board of directors?
Right. Or do you need a professional tone, a humorous tone, an urgent one?
Exactly. And most importantly, you set negative constraints, what the model should absolutely exclude from its answer.
Which leads us right into the final piece of the blueprint, which is output structure. And this is where it really clicks for me. You demand explicit output formats like bullet points, markdown tables, or a JSON schema.
Yes, JSON is a perfect example.
Because if you ask the model to format its response as a JSON schema, you aren't just formatting text anymore. You are formatting raw data so that another piece of software can instantly ingest it, parse it, and trigger another action without a human ever having to read it.
Exactly. You are literally turning text generation into a functional API. The implications of that are profound. You are shifting the output from something a human consumes to something a system consumes.
Wow. So when you combine all four, the specific verb, the restricted persona, the strict constraints, and the machine-readable output, the quality just skyrockets.
It absolutely does. But, even with that perfectly constrained environment, there's a known limitation.
There's always a catch.
Right. If you feed a highly structured prompt to the model, but the task involves dense logic puzzles, heavy mathematics, or complex multi-step reasoning, the model will still hallucinate. It hits a mathematical wall.
And overcoming that wall means we have to move beyond chat and get into advanced prompting techniques.
Yeah, we have to manipulate the tokens themselves. That mathematical wall exists because of how the attention mechanism functions inside the neural network.
Meaning, if the leap in logic between the question and the final answer is too vast, the model just loses the thread.
Basically, yes, it cannot maintain the contextual link. So, to fix this, we transition from zero-shot prompting to few-shot prompting.
Okay, zero-shot being what most people do by default.
Yeah.
Right, just giving the AI the task with 0 examples of what success looks like and just hoping its pre-trained weights figure it out.
Yes, zero-shot relies entirely on that basic blueprint we just discussed. Few-shot prompting, however, involves providing 2 or 3 specific input and output pairs right inside the prompt before you ask it to solve the actual problem.
It's like feeding it the script mid-scene. Like, if you wanted to classify the sentiment of customer reviews, you provide a fake negative review example and a positive review example mapped to their correct outputs.
Exactly. You're giving the model a micro-training session right there in the context window. It allows it to infer the exact logic and syntax you require.
Okay, so that handles pattern recognition. But what about actual reasoning? Like those math word problems that always seem to trip up AIs.
For that, the sources point to chain of thought prompting, or COT. This involves a surprisingly simple instruction. You literally just tell the model to think step by step.
Which is crazy that that works. It sounds like we are treating the AI like a high school math student. Like if I just ask the student for the final answer, they might guess and get it wrong. But if I force them to show their work on the chalkboard step by step, they suddenly arrive at the right conclusion.
And the mechanics of why that works are fascinating. By forcing the AI to generate intermediate reasoning steps, listing the known variables, deriving the equations, computing the math, you're forcing it to generate a visible reasoning trace.
So it's building a stronger contextual bridge token by token.
Exactly. It prevents it from skipping ahead and predicting the wrong final token. You are expanding the computation time. Because the model processes one token at a time, forcing it to output its internal logic step by step gives its attention mechanism more relevant preceding tokens to look back at when it finally calculates that end answer.
That makes total sense.
And researchers have evolved this even further into a technique called least to most prompting.
Okay, let me try to ground that one in a real-world scenario. Let's say you're asking an AI to diagnose a massive sudden drop in e-commerce sales. If you just ask for the cause, it might guess based on generic business trends, right?
Right, the zero-shot approach.
But with least-to-most prompting, you force the AI to build its own investigative roadmap before it even tries to answer. So it says, subproblem 1, check website uptime logs. Subproblem 2, analyze payment gateway error rates. Subproblem 3, review regional traffic. It breaks the giant problem into manageable subproblems and solves them stycherationally.
Exactly. The model is effectively self-directing its reasoning trace. And for the most rigorous applications, developers go even further and use complexity-based prompting.
Which sounds intense.
It is. This involves adjusting the model's temperature, which controls the randomness of token selection, and forcing it to generate multiple, completely different chains of thought for the exact same problem.
Wait, really? So it answers the same question multiple times?
Yeah. The system then aggregates the conclusions and takes a majority vote. You are essentially asking the AI to solve the problem 3 different ways to see if all 3 computational paths converge on the same mathematical truth.
Oh, wow. Okay, so we are talking about adjusting temperature scaling, generating multiple reasoning paths, aggregating majority votes. This reveals something huge. Advanced prompt engineering isn't just about regular people typing cleverly into a browser interface.
No, not at all.
This is actual, complex software architecture running invisibly behind the scenes.
Yes. The modern AI applications you interact with daily, the customer service chatbots, coding copilots, autonomous agents, they rely entirely on this architecture. When you type a message into a chat window, your text is just a tiny fraction of the actual prompt the language model receives.
Because it's wrapped in all this other stuff.
Right. The foundation of this system relies on what are called base prompts, or system messages.
Walk me through the mechanism there. How does a base prompt actually exert control over what the user types?
So behind the scenes, developers construct a master system template. When you submit your question, the software appends your text to this hidden system template to form a single input array. Crucially, the model is engineered to process the system token first,
Okay.
and it assigns it a higher attention weight than the user's input. This means the base prompt, which establishes the persona, the safety guardrails, the absolute restrictions, has mathematical priority over whatever you type next. Ah, okay. So the system token basically acts like an impenetrable bouncer. It intercepts the user's query and forces it through the established constraints before the generation even begins.
Exactly. But the sources highlight that base prompts are only half of the back-end architecture. The other half is context injection, which is widely known in the industry as retrieval augmented generation, or RAG.
RAG, I see that acronym everywhere now.
RAG is the definitive solution to the hallucination problem in enterprise AI. Let's say you ask your company's internal HR bot, what is our specific work-from-home policy?
Right, if the system just sent that question straight to the model would hallucinate some generic corporate policy based on its training data.
Exactly, because it hasn't read your specific HR manual. But RAG intervenes.
It intercepts the query. Yes. It converts your text into a vector, a coordinate in a high-dimensional mathematical space, and queries a vector database containing all of the company's internal documents. It scores those documents for semantic relevance, retrieves the specific PDF of the work-from-home policy, and injects that raw text directly into the hidden prompt alongside your original question.
Wait, so it literally pastes the document into the prompt behind the scenes?
Literally. And the mechanism of injecting that context is what mathematically prevents the hallucination. The final prompt explicitly instructs the model's attention heads to prioritize the injected text over its pre-trained weights.
So the instruction is fundamentally Answer the user's question using strictly the provided context. If the answer is not in the context, just say you don't know.
Right. By restricting the probability distribution entirely to the retrieved tokens, you guarantee an answer that is grounded in your proprietary data.
Okay, I understand the architecture now, but I have to push back a little on this whole prompt engineer job title.
Fair enough. Let's hear it.
I hear you explaining vector retrieval, system tokens, attention weights. But couldn't a traditional back-end software engineer, say a senior Python developer, just read the API documentation and learn these prompt formatting techniques over a weekend? Why does this demand an entirely separate job title pulling massive $300,000 salaries? Is it just industry hype?
It's a completely valid skepticism, but you have to remember a traditional software engineer writes deterministic code. If X happens, execute Y. Large language models, however, are inherently probabilistic.
Meaning they are unpredictable.
Exactly. You cannot write a simple unit test that expects a perfectly identical string of text every single time. A Python developer is trained to manage logic gates and syntax. A prompt engineer, on the other hand, is trained to manage statistical variance, linguistics, and continuous evaluation.
So the day-to-day workflow is just fundamentally different from traditional coding.
Entirely different. A prompt engineer is constantly version controlling prompts, tracking how a minor vocabulary change alters the output distribution. They run rigorous A/B testing across thousands of generation cycles, utilizing automated evaluation frameworks like LLM as a judge to measure semantic similarity scores.
Wow. Okay.
They analyze logs of failed interactions to identify edge cases where the constraints failed, and furthermore, they must possess deep domain expertise.
Which actually makes total sense. Like, if you are building a legal compliance AI, the prompt engineer must understand how a regulatory lawyer interprets nuance to properly construct those few-shot examples we talked about.
Exactly. You cannot evaluate whether a financial forecasting copilot's output is accurate if you don't understand corporate finance yourself.
Right, so the prompt engineer is bridging domain expertise, probabilistic software testing, and deep linguistic control into this single, highly iterative QA loop.
Yes. And the data across the industry strongly supports that conclusion. It is a rigorous, iterative craft. It requires evaluating the model's behavior across vast data sets. It is not just about finding magic words. It's about engineering predictable reliability out of an unpredictable statistical engine.
So, distilling everything we've covered from the sources today, prompt engineering is the disciplined, necessary translation layer between messy, unconstrained human intent and precise, tokenized machine execution.
That's a great summary.
And for you listening, if you want a practical roadmap to leverage this architecture yourself, the sources suggest a clear progression. First, don't just play around. Pick a highly concrete task. For example, I want the AI to explain SAP CIP enterprise code to a newly hired junior developer.
Right. Setting that specific, measurable goal is the mandatory first step.
Next, initiate the interaction with a simple zero-shot prompt. State the clear task and your desired output format. When the output inevitably misses the mark, maybe it's too dense or assumes too much prior knowledge, you iterate.
You apply the blueprint.
Exactly. Add the constraints. Limit the explanation to 3 paragraphs. Add the persona. You are a patient senior engineering lead. And if it still struggles with the technical logic, transition to few-shot prompting by providing examples of how you personally prefer code to be explained.
And finally, force it to think step by step before generating the final summary. You build the scaffolding piece by piece, monitoring how each variable alters the output.
And once you engineer that optimal prompt, you systematize it. You save it as a template to be deployed repeatedly. You have essentially coded a customized microapplication using natural language.
It completely reframes the interface, doesn't it? You are no longer just chatting. You are coding the parameters of a highly complex probability engine.
It really does. But as we wrap up this deep dive, there's a lingering implication here that goes way beyond just writing better code or saving API costs. We've established that prompt engineering is currently the essential bridge. We have to be the ones formatting our thoughts into rigid personas, strict constraints, and explicit chains of thought so the machine can comprehend us.
Right, the burden of translation currently rests entirely on the human user.
Exactly. But here's a thought I want to leave you with. What happens when these underlying models become so incredibly advanced that they no longer require our highly structured, engineered instructions?
Oh, that's an interesting question.
Right. What happens when the AI can intuitively map our vague intent perfectly without needing us to explicitly define the probability space? Will we gradually lose our own hard-won ability to articulate exactly what we want because the machine always just fills in the blanks for us? Or, conversely, will we finally be free to think purely in high-level abstract concepts, knowing the artificial intelligence will flawlessly build the bridge and handle the execution?
It really forces us to question whether the discipline of explicitly articulating our thoughts is a fundamental human necessity or just a temporary technical limitation we are about to outgrow.
It's a profound shift in human-computer interaction to ponder the next time you open a chat window. Thank you for joining us as we explored the hidden mechanics of prompt engineering. We will catch you on the next